Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to take a look at the types of VPNs. We'll be discussing remote access VPNs, SSL VPNs, site-to-site, IPsec VPNs, GRE over IPsec, dynamic multipoint VPNs, IPsec virtual tunnel interfaces, and then finally, service providers MPLS VPNs. This episode is part of my series on enterprise networking, security, and automation for the Cisco Certified Network Associate, also known as the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Remote access VPNs are typically initiated by the end user. When they need to make that connection into the corporate office, they start up that connection, they initiate that connection. These remote access VPNs allow your remote users or your mobile users to connect into your enterprise network. Now we have two types of remote access VPNs. One is clientless and one is client-based VPNs. For the clientless VPN, you can think about this as a secure web page. It uses the SSL certificates in a web browser. And so think HTTPS here. And when they access this page, it gives them the connection for the information they need from your corporate network. The client-based VPN requires the user to start up a program. One of the more common programs out there is the Cisco AnyConnect Secure Mobile Client. That needs to be installed on the device connecting in. A lot of times, this is how the IT staff make sure that this client is able to connect in. They have to install that Client Connect software, that AnyConnect software. When the client wants to initiate that VPN connection, they start up the Cisco AnyConnect Secure Mobile Client. They enter in their credentials and then they log into the network, and their laptop, their mobile device, appears like it would be just on the corporate network in the headquarters building itself. IPsec VPNs and SSL VPNs. Once again, an IPsec VPN there's a piece of software that needs to be installed on the client. One of the softwares here is Cisco AnyConnect. And so that software needs to be installed and set up for the client to use it. Here, SSL, this is your HTTPS connection. It uses the public key infrastructure and digital certificates to authenticate users into the network or the portals they're allowed to connect into. Now, the type of VPN you implement is based on the access requirements of the users and the organization's policies. There's some advantages and disadvantages to both, and you need to decide which is the best for your organizations. As we look at the chart here, we see applications supported. Because IPsec encrypts all traffic and encrypts all IP-based traffic, it will use, or any application that uses IP will be able to be used over an IPsec VPN. Now, if it's an SSL VPN where you're going through the web browser, that software, that application needs to be built to be used through a secure web browser. For authentication strength, IPsec, it's very strong, and it's a two-way authentication. We shared keys or digital certificates, and a lot of times, like I said, the IT staff has to install that software, so that verifies that that user has the rights to use that VPN software. Now, SSL, they consider that moderate for security authentication strength. It's a one-way or two-way handshake, however you set up your SSL certs, but it is still based in that web browser, so it's a little less secure than an IPsec VPN. Encryption strength. Encryption strength here is the IPsec VPN is considered strong. We can have key lengths here of 56 to 256. The longer the key length is, the harder it is to decrypt that data if you don't know what the key is. For an SSL, it's moderate to strong. And the reason it's moderate to strong here is you can have keys as short as 40 bits long there, but it does go up to 256. So once again, how you initiate or how you set up your HTTPS, your SSL VPN will determine how strong that encryption strength is. So if you set it to use the 40 key encryption strength, it's going to be a little less secure than the 256. So if you set them up correctly, they both can be a strong encryption strength. Then we have connection complexity. How complex is it to connect into our network? Well, with the IPsec, that end user has to have that client installed, and then they may have to do some configuration. And so for the end user, that may be a little complicated. That's where we get the medium here. For an SSL VPN, that's going through that web browser again, that using public key exchange, that complexity is fairly low. A lot of times it's just, you have to make sure you put HTTPS at the beginning of your web address. And then finally, we have the different connection options. For IPsec, it's limited by what the software will handle. Only certain devices can connect into that IPsec VPN. Now, what are those devices? Those devices have to support the IPsec client software. A lot of Windows systems support it, some mobile devices support it, but if you're looking at other devices, you have to see what your client software will support, and that will determine what devices it is. Now, if you're doing the SSL VPN, it's very extensive. And why it's very extensive, all you need is a web browser that handles HTTPS, and you can connect into the portals to get that information you need. In a site-to-site IPsec VPN, we connect up networks across untrusted networks like the internet. On the left side here, we have a laptop. That laptop connects into the local area network, and then we have our VPN gateway. A lot of times this is also referred to as our edge router. This edge router encrypts the traffic. And then when the traffic actually hits our untrusted networks, the internet, that traffic is encrypted. So if somebody does intercept it, they can't read what's in that traffic. So the traffic going across the internet is encrypted. Then technically the tunnel connects into the VPN gateway, but what happens a lot of times is it has to go up to the edge router here at your corporate network, and then that edge router will route it to our VPN gateway. And then that VPN gateway, that'll establish this tunnel here, and it will encrypt traffic between the one edge and the other edge here. It'll encrypt the traffic going back and forth, and that's where we get our tunnel. Now, when this laptop, this client connects in, they don't have to do anything special. They don't have to run a client. They don't have to go into a web browser that supports secure websites. They just connect into the network, and because the VPN gateway, that edge router, does the encryption and decryption, they don't have to run anything special here. Now, this VPN gateway, it encapsulates and encrypts that outbound traffic. As we go through the VPN tunnel to the VPN gateway, once again, the actual traffic may have to flow through the internet to the edge router and then to the VPN gateway, but it still establishes this tunnel where data goes in one side, comes out the other. After the VPN gateway receives that data, it decrypts it and then sends it on to the rest of your corporate network. I hope you're liking this episode on types of VPNs. If you have the time, please leave a comment and let me know what you think about the different types of VPNs. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. GRE is a VPN tunneling technology. IPsec is a VPN tunneling technology. A lot of times these two are used together. Now, the reason they're used together is because GRE does some things that IPsec doesn't, and IPsec does some things GRE doesn't. So GRE, the generic routing encapsulation. What this is it's a non-secure site-to-site VPN tunneling protocol. Non-secure. It does not encrypt your data. So if you just use plain GRE, generic routing encapsulation, you can set up a VPN, but it does not encrypt your traffic. Well, why bother set up your VPN then? Now, VPN does not support encryption by default. The reason we use a GRE tunnel is the GRE, it can encapsulate other network layer protocols. We can encapsulate multicast, broadcast traffic. IPsec cannot do that. IPsec is only a unicast protocol. Now, if we have multicast and broadcast we need to send across our VPN, we have to use the GRE because it will handle the multicast. Now, that GRE packet we can encapsulate into IPsec. So you have your data, then we wrap it in a GRE tunnel, and then we wrap that inside of the IPsec. The GRE allows us to send the multicast and broadcast, but then when we wrap it inside that IPsec, we get our encryption. Standard IPsec VPNs, and it's not GRE, can only create a tunnel for unicast traffic. And that's why we have to encapsulate our GRE inside of that. One of the main reasons why we want this GRE over IPsec is because it handles that multicast traffic. The GRE handles the multicast traffic, IPsec encapsulates it, encrypts it, but multicast traffic, these are your routing protocols. The routing protocols that figure out the best way across your network, the best way to get to its destination. With GRE, we can take these multicast updates, encapsulate it, and send it across our VPN connections when we encapsulate it inside of IPsec. When we actually look at the GRE over IPsec, we see that there's a couple sections to this information we're sending. The first one here is what we have is the passenger protocol. The passenger protocol, that's the original packet that we're going to encapsulate. Now, this could be IP version 4, IP version 6, a routing update, whatever we're sending across this connection, that's the original piece of information. Then we have the carrier protocol. This carrier protocol here for us is GRE. That's where we're going to encapsulate the passenger protocol. And so this passenger protocol now gets wrapped in with the GRE. Then once we have our carrier protocol, we get into our transport protocol. And this is the protocol that will actually be used to forward the packet. And this could be IP version 4 or IP version 6. So however your network is set up, we can then encapsulate it, and it takes all of this, puts it all together, and now we can route this one, we can forward it through our network to the destination. When it gets to the destination, we take off that transport protocol, then we take off the carrier protocol, and then we're able to send on that passenger protocol, that original message, to wherever it needs to go onto the network. Here's an example of it from a production setting. You have your two offices. We have the branch office, we have your HQ office. And we have these two routers. And these two routers need to exchange OSPF routing information. Now, this routing information has to go over the internet. The internet's an untrusted network. You don't really want to send your routing information unencrypted over the network. And so HQ has to communicate from the router to the internet to the branch network. And this is where GRE over IPsec comes in. It forms this tunnel. And so HQ router and branch router, they look like they're directly connected because we've set up this IPsec tunnel with GRE. And how this works is when we have to send an OSP update across the network, this is the original packet, so this is OSPF here. This is a multicast. And this multicast is not supported with IPsec alone. And so this is where we need the GRE tunnel. And what we do is we take that and we wrap our OSP original IP packet, this multicast here, we wrap it in the GRE tunnel. Now we're able to route our updates across the internet. But these updates, because it's GRE, is not encrypted, and that's where we have to take and put the IPsec, around the GRE, and now that encapsulates it. And so the OSPF packet, that's the passenger protocol, gets encapsulated by the GRE, which is the carrier protocol. So it carries that original packet, and then that gets encapsulated again by the IPsec VPN tunnel that does the encryption and also forwarding of the packet. Then it can go from HQ to the branch de-encapsulates it, takes the VPN or IPsec VPN off, then it de-encapsulates again, takes the GRE information off of it, and now we have the original IP packet, that OSPF multicast, and the branch router can then process that. When an enterprise adds in a lot of sites, all of a sudden your company's doing really good and you have all these branch locations, remote locations that are starting to pop up, and you have to tie them back to your network. Normal VPNs, IPsec, GRE over IPsec just isn't a sufficient way to do this. What we can use is this dynamic multi-point VPN. And once again, we do have the acronym for it. It's DMVPN. And what this DMVPN is, the dynamic multi-point VPNs, it's a Cisco software solution, meaning it's Cisco proprietary. You have to buy it and license it from them. But if you have lots of VPNs, if you have multiple VPNs to different buildings, different sites, it makes the administration easy, dynamic, and scalable. What this DMVPN does is it simplifies that VPN configuration, and then it also provides a flexible option to connect a central site with the branch sites. We use the hub and spoke configuration to establish a full mesh topology. Now, how does that really work? We have our hub here. So we see our hub. This is your headquarters. This is your main office here. And each one of your remote locations, they are considered on a spoke. The hub location has a static IP address. So this is a static IP address. Your spokes can get a dynamic address. Now, why is that nice? Because that way you don't have to go out and lease an IP from your service provider. You can just get an IP address from their DHCP pool. You don't have to pay extra for it. And if that address changes, no big deal. And what happens here is this spoke connects into the static IP. So this is dynamic here. So this is a DHCP address. It gets there. It connects into the hub where it has that static IP address, and it sets up the communications. Those spokes establish secure VPN tunnels with the hub site. And so spoke 1 sets this up. Spoke 2 gets a DHCP address. It knows the static address to connect into, and so now we set up our VPN tunnels here. And you can continue adding in as many as you need, and of course as many as you paid in for your license for this software. But you can go through and you can add up to hundreds of VPN connections in there. And what does it take to spin one up? You get your hub here, you get it a DHCP, and then you point it to this static address, and you are now connected. Now, each site, each one of these spokes is configured using a MGRE. So it's MGRE. What the MGRE is, the multi-point generic routing encapsulation, allows a single GRE interface. So each one of these creates a GRE interface to dynamically support multiple IPsec tunnels. And so this MGRE isn't configured necessarily on the ends of the spokes, but it's configured up here on our hub. It gets configured there, and then we can have our multiple GREs from each one of these spokes connected in. As your company starts transferring data back and forth, all of a sudden you may determine that, hey, spoke 1 and spoke 2 location one and branch one and branch two need to communicate. What they can do is set up an on-demand dynamic multi-point VPN. So we can go ahead and do this. Even with both of them having a DHCP address, a dynamic address that could change and will change, because they communicate back to the static, to the hub, that hub goes through, does the initiation, and keeps track of the information. So location one, branch one, can set up a on-demand tunnel to branch two. They can transfer data directly back and forth. It's nice software. It works beautifully, but of course you got to purchase it from Cisco. Another type of VPN is the IPsec Virtual Terminal Interface, or VTI. This IPsec VTI is another type of VPN. And what it does here is it helps simplify the configuration process required to support multiple sites and remote access. Now, the IPsec VTI configurations are applied to a virtual interface. And so we set up a virtual interface on your edge device. And so this is a virtual interface here. This virtual interface you set up and you apply the configurations there instead of a static mapping to your IPsec sessions to that to that physical interface. Now, this VTI is capable of sending and receiving both IP unicast and multicast encrypted traffic. Unicast and multicast encrypted traffic. What this means is if you have to send routing protocols across your network, you can use IPsec VTI and not have to configure GRE tunnels. Now, IPsec VTI can be configured between sites, or you can do a hub and spoke topology. In today's IT world, service providers use a multi-protocol label switching in their core network. Now, what this does, MPLS traffic gets forwarded using labels. These labels can be independent of the technologies that are being used, and that's why a lot of providers like to use MPLS. It doesn't matter what connection they're using to the internet. Broadband, cable, DSL, fiber, wireless, some sort of digital serial line. This traffic is forwarded using labels. It's secure because those customers that use MPLS VPN from a service provider, they can't see each other's traffic because they're labeled, because they're encrypted. They just can't see their traffics. Now, MPLS here, they can be a managed VPN solution. Now, what does a managed VPN solution mean? You contract out the service to a service provider. They are responsible to provide you the service that you probably agreed to in your service level agreement. And it's not your responsibility now to encrypt that traffic, to protect that traffic, to route it to its destination. Now, MPLS VPNs, they are typically offered, once again, by your service provider. And there's two basic types. We have a layer 3 and a layer 2. The layer 3, the service provider participates in customer routing by establishing peering between the customer routers and the provider's routers. And so they come in, they provide that peering, layer 3 IP addressing, IP version 4, IP version 6. They provide that. Now, with a layer 2 MPLS VPN, the service provider is not involved in the customer routing. What happens here is the provider deploys a VPN LAN, and that emulates the Ethernet multicast LAN segment over MPLS. No routing is involved. The customer's routers effectively belong to the same multicast network. All of your routers basically can talk to each other. The provider does not have any of their devices involved. Your routers has a VPN to your other routers, and no other equipment's in the way. Now, which one is the best for you? You have to look at your company's needs. what I see out in industry is a lot of the smaller companies that are doing this, and I guess I shouldn't say smaller companies, but a lot of companies that have like 2 or 3 or 4 locations, they do the layer 3 MPLS VPN. When you start getting up into the 10s and 20s of locations, then you start looking at the layer 2 MPLS VPNs. It was my pleasure to provide you with this wonderful episode on types of VPNs. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode on my series of enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.